Ladies and gentlemen, welcome back once again, and I hope that you had a good lunch. Ladies and gentlemen, it's time to commence with our very special session on Indian Railways. And I'm now going to take the privilege of requesting Mr. Mangal Dev, Director, Rail Systems Company, Hitachi India Private Limited, to please deliver his welcome address and also share with us his presentation. Please welcome Mr. Mangal Dev, ladies and gentlemen.
Thank you very much. Good afternoon, ladies and gentlemen. It gives me immense pleasure to welcome you all to this afternoon session on Hitachi Rail System. And we are going to talk about what Hitachi Rail System is doing globally and what we have up our plan for India. And therefore, I'll take you through this presentation in details. So first of all, let me give a quick introduction of Hitachi Rail System business. We are part of close to 90 billion Hitachi conglomerate and present majority of our presence is in Japan and then in North America, in China, Asia, and other areas. So, in terms of different business that we do, the social infrastructure business that we are going to talk about today, railway system is part of that, and we take pride in doing innovation in the social infrastructure framework and providing the latest innovative solutions to our customers. The overview of a railway system company, you can see that we are lined up for providing complete rail system solutions, whether that caters to the urban railway or the intercity railway or the high speed and the very high speed, in terms of providing the rolling stock and the maintenance. Along with that, the electrical equipment. In addition to that, the complete transport management system, the control system, including the signaling and the traffic management system, the power supply system, and the associated system that goes with that. And we are close to 1.4 billion globally. And the good news is that we recently have grown bigger inorganically, and we have now acquired two Italian companies in the railway sector, Hitachi Rail Italy, that is the new name, that basically caters to the rolling stock solutions, and also Ansaldo STS, which mainly looks at signaling and train control, traffic management system, and also turnkey contracts. So put together, we would almost be close to 3.5 to 4 billion from next year onwards. In terms of rolling stock, Hitachi, as I mentioned, we cater to all the three major segments. The urban transport, which comprise from the low speed, low capacity monorail system to medium and high capacity metro system and the commuter railway, to the intercity like 160 to 200 kmph, and then the high speed and the very high speed starting from 200 onwards all the way up to 350, 360 kmph. And we have lined up a majority of our systems available in Japan and globally. The Shinkansen technology, the high speed projects that we have put into operation in UK, the first high speed in UK called the Javelin project, and the second, the IEP Intercity Express program, and of course our tilting trains that we have put into operation in various countries, and the bi-mode solution. These are energy efficient, or I would say the alternate energy concepts that we have in operation, which saves on energy as well as uses the green concept catering to the climate change. We have the air train concept, a train which is advanced in technology based on aluminum design, and it is adaptive, so we can adapt it to various requirements. Therefore, in all, we provide the entire railway system solution to our customers globally. And to our record, mainly in Japan, this particular presentation shows different projects on the conventional network in Japan and the Shinkansen, the new railway network in Japan. So you can see across the country we have our presence. Worldwide, also, we have number of projects, as I mentioned, in Taiwan, Australia, China, UK, UAE, Singapore, etc., etc. If we look at only Shinkansen in Japan, we have the impeccable record in terms of our engagement since 1960s with the Japanese railways, and to date we have delivered more than 2,500 vehicles, therefore taking a very, very strong lead in Japan. And this is the A-train concept that I talked about. So we have delivered more than 1,000 such vehicles adopting the A-train concept, whether it is in our metro system, commuter system, or the Shinkansen system. What it actually means is you have the most advanced technology in construction of the most critical part, which is the car body shell, using aluminum extrusion with very thin wall, hollow kind of structure, and you extrude it over a length of almost the length of the vehicle, which is 25 meters. And this is a very, very high technology kind of process and not available everywhere globally. And Hitachi masters this kind of technology. And then you use the technology of friction stir welding to put all these panels together to construct the final car body. And then we use our own traction system based on IGBT design or the silicon carbide that we are already researching on, and our bogie system, therefore leading to a modular concept of construction of the train, so-called the A-train. Just to give you the evolution of technology on the aluminum car body shell, long time back it used to be semi-stainless steel car body, and then it moved in on one side to stainless steel car body, on the other side to aluminum single skin car body, and latest which I talked about is the aluminum double skin thin wall extrusion. So this is what is our latest technology, in addition to, of course, the stainless steel that we offer to various customers. It has its own merits and advantages. For example, this leads to a very sustainable rail transport because of easy recycling, energy saving, and lesser CO2 footprint. And this is because of the construction, the noise, and the heat insulation that it brings in much better ride comfort and the ride experience by the passengers. Of course, it saves energy because of the weight saving that it brings on. It also saves on the wear and tear of the brake system because of the weight component. And this does not need, the technology that we bring in does not need any external painting, so to say, other coatings that generally are required. So this can be used as it is, and therefore is really a sustainable rail transport system. Next I'm going to talk about is the portfolio of traffic management system, including the signaling system and passenger information system. And Hitachi today is taking a lead, whether in Japan or in outside Japan, in China or in Europe, starting from UK, which has been our door of entry into Europe through UK, and also now with the help of Ansaldo STS, which is the signaling and turnkey company, to go further global and bring this technology to India, and I'll talk about in more details about India. So this technology, signaling and train control, encompass the automatic train protection, which provides the overall safety on the network, and the automatic train operation, the communication-based train control system, which is primarily used on a metro and the urban transport system. So therefore, we also have an edge in this kind of technology deployment, and we take pride in sharing with you gentlemen that, ladies and gentlemen, that the network in Japan today, the Shinkansen network, where Hitachi is a leader in providing our comprehensive traffic management and signaling and train control system. There is a zero accident case, therefore high level of safety, and also in terms of punctuality, you can see only 0.6 minutes per train annual average delay that has been recorded. So it's really something which involves Hitachi working with the Japanese railway hand in hand and developing a complete railway system, not only just focusing on the components of the signaling system, but providing a comprehensive railway system. We do much more than that, which I'm going to cover in the next slide. This gives you a snapshot of the architecture of a traffic management system and signaling system. So you can see that in terms of the play of IT is enormous. The digital platform that Hitachi has created, it has been deployed extensively in creating the Shinkansen or the metropolitan urban transport, which is ATOS, and the Cosmos is related to the Shinkansen system. We have other elements, traffic management system, SCADA, security management, seat reservation system. So we not only provide the traditional signaling and passenger information system, but we also do a little bit of what in India is done by CRIS. And in the safety arena, we have the automatic train protection, automatic train operation, using the interlocking technology, the securing the tracks, and communication of this information onto the train and onto the operational control center, and also incorporating the technology not on the track but also on the trains, making the trains much more intelligent in terms of taking decisions as how they locate the other trains on the network, and they talk to each other and decide how fast or how slow they have to move, therefore ultimately providing the full safety as well as the capacity of the network, which is very important. So a capacity in the network defines the overall cost productivity, and therefore could lead to the what ultimately results in the per kilometer passenger fare or per kilometer freight fare, that is the revenue, and that can be passed on to the ultimate consumer by the Indian Railways when they will look at these solutions in a comprehensive manner. So in terms of traffic management system configuration, this is quite clear that in addition to the central control office or the OCC, we look at the passenger information system, the PIS, and then the assistant station master. So we have the equipment on the track in the station master's office, in the operational control center, and all this gets integrated to provide the overall operational and the safety requirement on the network. So going into the details of the traffic management system function, you can see that how the timetable that is created on a particular network, it is controlled by the computers through the software, and then how it is implemented, any aberration that happens in the system, how the system comes back and offers the suggestions to the operator whether to make a particular change or not, or how to reroute the trains. So all the disruptions that happen in the network can be managed automatically by this system, because it interfaces with all the staff, it interfaces the train driver, the signaling system, the passenger information system, and the power supply. So you can look at this itself is a very comprehensive system that has several stages of implementation. So you could implement it as just a traffic status monitor system. You could then in phase 2 or in step 2, you can move to centralized manual routing setting, and the step 3 you can look at automatic route setting, and then the step 4, which is the ultimate, the intelligent railway system, can be created by using the core feature as well as the value added features of this particular technology. So, want to take you through specifics of what we have done in, let's say, right now I'll talk about Japan. The ATP system in Japan came into force long time back before even it was adopted elsewhere in Europe. Now in Europe we have a common system of interoperability called ERTMS or ETCS, but long time back in Japan this technology was developed by Hitachi and offered to the Japanese railways, therefore providing the entire network with this kind of system and placing Hitachi as #1 position. In terms of traffic management system, we have, as I mentioned, not only adopted on the conventional lines of Japanese railways, also on the urban network, and majority of it you can see in the Tokyo metropolitan area, which has a population of 43 million, and the dense railway network encompassing the Shinkansen, the commuter and the suburban and the metro. So managing such a network is much more mind-boggling, and we have been doing this together with our customers in Japan, and we happily announce we share the largest share of this market because the customers like us, they like Hitachi solutions, and therefore we are able to offer to such a dense area, the Tokyo metropolitan area, the solution that we provide. This is a little bit more detail on the computerized safety maintenance and operation system of Shinkansen, the Cosmos. So it takes care of the total system railway operation. It's a highly decentralized system and applied at Tohoku, Joetsu, Hokuriku Shinkansen, and 3 lines, 37 stations. Of course, the details are here. The next one is not only in Japan, we have taken this technology to wherever the Shinkansen has gone. So one of the project is the Taiwan high speed, where we have adopted this system over 300 for the speed of 300 kilometers per hour, and you can see the headway is also very, very tight on this network, and the kind of traffic that is carried, close to 40 million passengers capacity is being carried on this Taiwan high-speed network, and the safety and the operation is managed by the Hitachi system on this network. In addition to that, I just want to share the other global deployment in Asia, including the ETCS, what we call in Europe. So similar system has been adopted in China called the CTCS. The CBTC system, which is generally used on the monorail and the urban transport system. The ATS, which is the automatic train supervision, ATC, automatic train control. In Europe, we are primarily doing projects together with UK Railways in implementing the first ETCS level 2 project together with our trains called Intercity Express program, and in other parts of the world. So we are deploying this solution globally. And just to share with you this beautiful example of Tokyo Metropolitan Yamanote Urban Line. It created the Guinness Book of World Record by carrying 3.6 million passengers per day. And Hitachi signaling and traffic management system is at the back of this particular performance of the network. More talking about ETCS and ERTMS, the CTCS, and comparing that with what we did in Japan. So I thought it will be good to share with you a quick comparison. The Japanese Railways digital signaling ATC system versus ETCS level 2. You can see both have lot of similarities, but number of equipment which is installed on the Japanese railway system is much smaller than the ETCS level 2, and the reliability and the availability is very high. You can see the numbers, and therefore this is suited, of course, to the requirement of the operator. So what I mean to say is that we bring the technology which can be adopted and adapted to the local requirement of the local network rail, and we are adopting this technology, as I mentioned, in terms of ETCS level 2 in UK, and we will also be implementing part of this technology in one of the projects that I will share the details in the next slides. So in terms of ETCS level 1, you have an intelligent train in terms of the computer being on the train and the driver looking at the signals in the cab. Also you have the signals on the ground. So this makes the ATP functional, and therefore the train is protected from the causing any accidents or causing any other abnormalities in terms of safe operation of the network. So different equipments that constitute this system: the onboard unit, the driver machine interface, the balise transmission module, and the antenna perform different functions to make this system as a complete system. In UK, as I mentioned, we have already been certified for ETCS level 2, and this system will also be operational on the IEP train that we are doing the homologation right now, which is a signature project for Hitachi to offer close to 866 vehicles in one single contract to modernize the entire UK fleet from existing diesel trains, the loco haul trains, to electrical multiple unit trains, and therefore also incorporating the ETCS level 2 in these trains. In China, as I mentioned, it is called the Chinese train control system. We have implemented level 2 and level 3. Therefore, we look at the market very closely as what are the specific requirements. We take the technologies and modify them and adapt them to the requirement of those local railways. In terms of the communication-based train control that primarily used for urban mass transit and monorail, I will just share with you that we offer this complete signaling and continuous automatic train control system, and this system is what is called the most flexible system in terms of putting the largest number of trains on a network with the technology of operation called moving block. So the safety block around a train moves along with it. Therefore, you do not have to dissect the railway network into segments or into sections, restricting only one train per section. So in this case, there is no section demarked on the network, and this safety zone moves with the train. Therefore, the train can really drive like you drive a car on the road, going very, very close to the car in the front, therefore putting the largest number of vehicles and giving a very safe system. And these are the kind of hardware that goes into it on the track side and on the train side, on board, and the track side with different kind of technologies, the communication system that goes with it. So this put together provides the complete system. In addition to that, it also requires or it adapts to what is called the automatic train operation. So generally the train operation is classified into GOA1, GOA2, GOA3 and GOA4. And if you look at the GOA1, you have the driver who is managing the train, who is driving the train. And on the other end, you have the GOA4, where the entire operation of the train is managed automatically by the signaling and train control system, and therefore you do not need a driver, and therefore there is no manual intervention in driving the train, and you can really follow the speed plan or the timetable on this train. And this system currently is adopted on a metro urban transport system because of its closed loop nature and the technology being classically developed for this kind of operation. Very soon this technology will be adopted to a mainline operation also, but we all the companies or all the industry is working towards that. Therefore, we offer this kind of flexibility in the operation. So in all, if we look at what Hitachi offers, so we start from the system integration methodology. We take different elements of technologies and put them together to create automatic signaling system, using the TMS, the traffic management system, the train protection and warning system, and or you talk about the CBTC system. So we put together these elements and create, but going forward we can expand and use the Hitachi experience coming from our other areas such as energy saving and energy storage devices, information communication system, information analysis system, and on the other side the maintenance of assets, rolling stock is also very, very important. And therefore, the designing and the construction of the depots where you carry out the maintenance and performing the maintenance of the trains in a very, very limited time. Generally, you have only 2 to 4 hours to maintain a train because you have to send the train to the network to perform its actual work to carry the passengers. Therefore, and when we look at further expanding it, we see that we can bring it lot of new elements. Therefore, taking this system, this knowledge to a next level and providing all kinds of modern technologies and providing a comprehensive future railway system, mainly riding on the ICT and the digital system that is put into extensive use. I thought I will also share with you a snapshot of our new brother, the company that we have acquired, Ansaldo STS. They deal with the signaling, train control, and turnkey operations. So they also follow similar, almost similar kind of system from a metro to a commuter to high speed and very high speed. And in terms of signaling, the main line and the high speed technologies, the ERTMS, European Rail Traffic Management System, level 1 and level 2, and of course the local country signaling system. So they offer also a very new set of solutions, and if you look at their presence, they are very, very global and they complement what we do at Hitachi. So when we get together, we will be able to offer our solutions not only efficiently, effectively, closer to our customers, being closer to our customers, but also globally, and be able to leverage this experience extensively. I just thought it will be worthwhile that not only we do the signaling and train control, but also monitoring of the fixed infrastructure, the fixed as well as the train infrastructure by deploying systems on the network which can find out whether a particular train or its particular vehicle has certain issues that will cause derailment or accident. So we have such technologies which can diagnose, sense, diagnose, and communicate to the operational control center or to the driver about such issues in advance so as to prevent such accidents and ill effects. Ansaldo STS also offers low capacity systems using a different kind of technology, where the network capacity is very small and you cannot afford to implement the premium technologies. Then you need to invent altogether what I call the low capacity, low cost technologies which can be deployed on much larger network. For example, in India, you have two very clear distinctions, the golden or now the diamond quadrilateral, which is close to 20% of the network, and the remaining 70 to 80 network is the low capacity, and that needs a different kind of signaling system. So we also offer